Assalamu alaikum YouTubers, welcome back to SLK Tools. Here in this section, we'll be learning in detail the material estimations just per dooms. Remember, we'll do the calculation only per RCC dooms, right? Also just remember there are many types of dooms, but here in this section, we'll be just learning the detailed calculation only per spherical dooms. Remember, the spherical doom just may be a half sphere, right? If you cut the full sphere in two equal parts, the one part is known just by a half sphere. Just look at the picture, right? The picture clearly show the doom is just a half sphere, right? Look at this one. Of course, this is a half sphere, right? And remember, the doom may be just a segmental sphere. This is not a half sphere. Look at the picture. This is just like a part of a sphere, right? To cut a little section or to cut a little segment of a sphere, right? And the calculation for a half sphere is quite simple and straightforward. And of course, for segmental sphere, this is just little complicated and challenging, right? Alright, let's do the material calculation for all these two dooms, right? But before starting the calculation, let me show you what's the volume and surface area of a sphere, because these guys will help us, right, in material estimation. And remember, the sphere volume is just 4 by 3 times pi r cube, and this is for solid sphere. Remember, the doom is always a hollow sphere, right? Well, we can use another formula like this one. The capital R just represent the external surface radius, right, in hollow section. And the small radiuses represent, the small R just represent the radius of interior surface, right, in a hollow section. And what's the surface area of a sphere? Remember, this is just 4 times pi r square. I think you're just confused, right? But don't be, because I'm gonna do an example for better understanding, right? And let's do, of course, an example. This is, of course, example 1, and we are asked to work out the cement, sand, crushed stone, and steel per given half spherical doom. The concrete is 124, and the steel is, of course, 1.5%. And only number 4 bar will be used. We are also informed to calculate external surface paint, which means we'll paint the external surface of the doom, so we need the area painting, right? And the doom just look like in this position, right? And remember, the external surface radius is just 7.5 and the thickness is 6 inches. To subtract the thickness from external radius, we can get the interior radius, which is 7, right? So the height or the rise of doom must be 7 feet. This is just a half spherical doom, right? I think this data is quite enough to calculate these materials: cement, sand, crushed stone, and steel, right? So I'll come straight over here into solutions, and my approach is the doom volume. Remember, this is RCC doom, which means this is concrete. So the doom concrete must be 4 by 3 pi r cube negative r cube, because this is just a hollow, right? A hollow doom. And this formula is, of course, just for a full sphere, right? What? We have, of course, a half spherical doom. So we must divide this formula by 2, right, to get the volume or the quantity of a half spherical doom. All things are given, so plug and check in this equation, we can get 4 pi times the greater R, which means the external surface radius is just 7.5. So 7.5 cube negative the smaller r, which is the interior surface radius, 7 feet. So negative 7 cube divided by 3 2s are 6. So if you use your calculator a little bit over here or your mind, you can get, of course, 165.195 CFT as the total RCC of this doom, right? And my next approach is just the steel. Remember, the steel is just 1.5%. And to remove the percent sign, of course, we divide the vector by 100, right? Or 100. Now, if we have steel 1.5 and 100, how much will be in 165.195? So we'll just multiply this vector with this, right? We can get, of course, 2.478 cubic feet as steel. The steel is in pound of volume. Remember, we need this guy in a pound of ton, kg, or another unit, right? Like quintal, etc. So to convert this steel, which is in form of volume, we'll just multiply this with unit weight of steel or with density. This time I have 222.323 kg per cubic feet, right? This is the mild steel unit weight. So we can get, of course, 551 kg, which is number 4 bar, right? I mean, we just need 551 kg number 4 bars. Now, what will be our net RCC? Actually, this is PCC now, right? We'll just deduct the steel volume from doom concrete. I mean, we have, of course, 2.478 cubic feet as steel. We'll just subtract the steel from the total RCC work, right? So 165.195 negative 2.478 cubic feet. We can get, of course, 162.717 cubic feet as total RCC. Actually, this is PCC, right? Because we have already deducted the steel. And my next approach is to calculate the external surface paint. Remember, just look at the example. We are just informed to calculate external surface paint, right? We'll just paint this external surface, right? Just the top surface. So how much area will be covered when we need to paint this surface? And after this, I'll just calculate cement, sand, and crust stone, right? I'm doing this guy a little first over here. And remember, what was the surface area per sphere? Of course, it was 4 times pi r square, right? This is just the formula for full sphere. We'll just divide this guy by 2 because our sphere is just half. Now it's quite simple because we have all data known, right? Which is 4 pi times the r is given 7.5. So 7.5 square divided by 2, we can get, of course, the area of paint, which is 3 pi 3.43 SFT, right? This is in area, right? And now let's calculate cement, sand, and crust stone. Remember, for cement, sand, and crust stone, we have a nice video tutorial in the same playlist named as, actually I don't remember now, but the name is, I think, how to calculate cement, sand, and crust stone and PCC work. I think this is the name of that lecture, right? Of course, you can search that, and I recommend you to watch this lecture first because there is a lot of detail in that lecture. Over here, I'll go just a little quickly, right? So my total PCC work, of course, which is 124, is just 162.717 cubic feet. And my approach is just to determine cement, sand, and crust stone. To calculate any of these 3 material, we have a nice formula. The material must be equal to ratio of material divided by sum of ratio times dry volume, right? What does this formula mean? If I need to calculate any material, say I just need to calculate cement, what's the ratio of material? Of course, look at the ratio 1 to 4. 1 just represent the ratio of cement divided by sum of ratio. What's the sum of ratio? Just add all these 3 guys, right? The ratio is 1 to 4. Add all these 3 guys, we can get, of course, 7. So 1 divided by 7 and times the dry volume. What's the dry volume now? Just look at over here. Dry volume is just the wet volume times 1.54. And the wet volume is given just over here, which is 162.717 cubic feet, right? And what's 1.54? It is, of course, just 54% of volume, right? To convert the wet volume into dry, we multiply the wet volume with this vector, right? So just the dry volume will be the wet volume, which is given 162.717 times 1.54, which is equal to, of course, 2 pipe 0.58 cubic feet. Just plug this guy over here in this equation. Of course, we can get the cement quantity 3.18 cubic feet. The cement is in form of volume, right? And of course, we need the cement to be in bags. To convert the cement into bags, of course, just divide the volume of cement by 1.25, because this is just the one cement bag volume, right? 1.25 cubic feet is one cement bag volume. We're here in Pakistan. If your country bag volume is just little different, no problem. Of course, you can use that factor over here. So we can get, of course, 28.64 bags. You can say 29 bags, right? And my next approach is just the sand. Just look at the ratio over here. The ratio is 1 to 4. The 2 just represent the sand, which is of course 2 times of cement. And of course I have the quantity of cement. I'll just multiply the quantity of cement with 2. So I can get the sand quantity, which is 71.6 cubic feet. Alright, so the next step is just to calculate the crust stone, also known by coarse aggregate, right? Just look at the ratio. The 4 just represent the ratio of crust stone, which is of course 4 times of cement. So I'll multiply the cement quantity with 4, right? I can get the crust stone quantity, which is 143.2 cubic feet. Here is our detailed result. The cement is just 29 bags. The sand is just 71.6 cubic feet. The crust stone is just 143.2 cubic feet. Of course, you can convert all these guys into secular, right? And the steel, which will be just a number 4 bar, is just 5.1 kg. And of course, the painting area is just 3.43 SFT. And this was our first example, and we have done it, right? This is the result. I just want to do another example, right? Example 2. Also, we are asked over here to work out the cement, sand, crust stone, and of course the steel per given segmental doom. Remember, in the previous example we had a doom just a half spare, right? Over here we have a segmental doom. This guy is just little challenging, right? And this may look like in this palm. The thickness is 6 inches, the height which is 4.5 feet. And remember, this is just a segment. If we just draw a full circle like in this palm, right? The radius of this full circle will be just 10 feet. And the interior radius is just 9.5 feet. Because just subtract 6 inches from external radius, we can get, of course, radius 2. Also, just h1, which represent the external height, which is 5 feet, right? Just add 6 inches with 4.5 feet, we can get h1. I think this data is just enough to calculate material in this doom, so I'll come straight to our hand to solutions. In the solution again, if I need to calculate cement, sand, crust stone and steel, I just need to calculate the doom volume first. And this is RCC doom, so the doom volume must be just pi times h square divided by 3 times 3r negative h. This is just the segmental doom or a segmental cape volume, right? And the idea is just look at this picture, right? This green zone just represent the doom, right? The segmental doom. And our 10 radius just represent over here the base radius, right? Okay, this is the total. If you just assume the doom as a total sphere, so this 10 feet just represent the radius of that doom, right? Or that sphere. The formula will just give you answer of a solid doom, which is a segmental doom, right? But our doom is just hollow. Look at the thickness is given, right? And two types of height are also given, and of course 2 types of radius are given, which means our doom is just a hollow, right? So what should I do now? I'll just subtract the interior doom from external doom, and this will be really, I think, easy and straightforward. Per external doom, I have a formula, this one. I'll just put h1, r1 and h1. right? Because all these guys just relate to the external surface, right, or the external doom. Now I'll just subtract the interior doom, right? So the formula is quite simple now. Because all things are given, I'll just plug and chug in, right? Just plug and chug in the external. We have pi feet as the external height, and the R1 is just 10 feet. H1 is of course pi feet. Negative, the formula just for interior doom is just in this form. Over here, H2 is just 4.5. R2 is just 9.5, and again H2 is just 4.5. If you do little mathematics with this guy, of course you can get the doom concrete equals 145.56 CFT. And this was really, I think, quite easy, right? There is nothing complicated. If you are facing any challenge, you can of course ask me and comment, or you can also call, right? Now our approach is just the cement, sand and crushed stone, of course the steel also. But I'll not calculate all these guys because a few minutes ago in example first, I just did this guy little bit, okay? Just let me go back over here. Just look at this guy. And the cement, sand, crushed stone calculation is over here, right? And of course the steel, let me just go little back over here, this one. The steel is 1.5%, and the same calculation will be just done in example 2, right? Which is, just look at over here, this one, this example. We have of course the quantity of this doom. Of course I can calculate cement, sand and crushed stone with the same process that I have done example 1. I think I'll not waste my time over here in this calculation, because if a thing is already done, so it's not required to be done again, right? So it's enough. Thank you guys for watching. See you next time. And what? Nothing, of course. Wassalam.